Okay, let's start with, I think Victor will join very soon. Oh,
Hello,
hello Victor, how are you?
I'm good. Happy New Year.
Yeah, Happy New Year for you too. Since you are on stage, let's start.
Yes.
The mic is yours.
Okay, so this will be a quick update. As you said, we are planning to move to this new format, but we are going to do a little bit like the old format, right? Okay, so this is the January 2024 update, the dev recap. Just a minute. It will be a quick one. Technical problems. Okay. So in the past month, we worked on the release of the machine emulator SDK. It's almost there. The last guards and fixes are under review. A bunch of things went in, like we deprecate and remove the old root FF, the one that was based on build roots. And everything now is based on Ubuntu, and it's built with Docker. And in the past, this took a long time, and now for machines it takes 3 minutes to have a full root fast. On some other machines, 6 minutes, but it's a really improvement to make file systems different and to include tools, etc. Also, we tackled some technical debt. We refactor how the emulator tests are done for a better organization and grouped everything together. It was scattered all over the place. And there is, in this SDK, the main feature releases the support for the microarchitecture ESET, right? And next on this line of work is the load rollup input that Pernambuco is working on. And there are also good news for what is to come. Eduardo resumed his work on Virtual. This will enable Sunodo and other components to access the host files from inside the machine while developing, of course. And there will be network as well. And maybe this is an alternative for the host mode. So he's resumed this work, and let's see. Alex also made a good progress on a Sunodo plugin that supports the hypervisor feature, so people can experiment with it. It's already built in the machine. It's looking cool. And finally, we are on this effort to unificate the output of the machine, right? And there is this library, libcmc, that's almost in the end, so we can move forward to the next step. So this was a quick update of things that we worked on the last month. And yeah, that's it. Thank you. Back to you, Paul. I think you're muted.
Okay, thank you very much, Peter. Let's see who will be the next.
Workflow for the dev, application developer. There are other possible workflows, but this is a common one. They will change the code, the application code. They will build it into an application snapshot for the Cartesi machine, usually using Sunodo for building it, Sunodo build. Then they will restart the Cartesi Rollups node and all the infrastructure on it related to it, the database and the services, APIs, etc. Eventually, the node will restart and it will start the Cartesi machine, which will load the newest snapshot that was built. Then finally, the developer sends the inputs to the development Ethereum node, for instance, Anvil running on his machine. And then it's basically the same workflow as the user. The developer sends the inputs to the node, the Ethereum node, the Rollups node reads the input, sends to the machine, gets the outputs, and then the developer gets the outputs from the Rollups node and checks whether the change that he made in the dApp made some difference, was actually what he intended to do. And this repeats a lot. So what's the pain of the developer? The redeveloping loop, when working on this kind of workflow, can take from several seconds to minutes. So it takes a lot of time to rebuild the machine. And even if you use Docker and cache stuff and don't have to compile everything again, you still have to boot the machine from scratch. This takes some seconds as well. Restarting the node takes some time, and now the infrastructure, sending the input and waiting for it to be mined. Then we have to wait for the latency between the services to inside the node to the input to be processed. So this takes a lot of time, and that's a major pain for the developer. So the proposed solution, we already have something like that, but the new one is called Nonodo. And what is Nonodo? It's a lightweight node for development for the Cartesi Rollups. It's supposed to be a replacement for the host mode and the no backend mode on Sonodo. The only external dependency is Foundry, which is a development tool that everybody that's working on Ethereum already knows and is already using. It's super lightweight as well. And it doesn't require Docker, so you don't need Docker installed to start using Nonodo and start developing Cartesi applications. And it's distributed as a 10 megabyte self-contained binary, so it's very lightweight, it's easy to download, and it's easy to get started. So what Nonodo is not, this is important as well. It wasn't designed for production. It's just for the development workflow. So for instance, it doesn't have persistence, so it doesn't have a database, it doesn't store anything other than in memory. It doesn't do optimizations. It's not supposed to handle like terabytes of inputs and store those inputs optimally. It will just store them in memory, and you probably don't need much there because you as the developer are sending inputs manually, so you don't need a lot of optimizations. And it also doesn't try to handle corner cases. This is all to simplify the code. So for instance, it doesn't handle reorgs and other cases that the actual node needs to handle when running in production. So the architecture is very simple. Nonodo is this blue box on the top. It starts several APIs, the Rollup API for the application backend, the Inspect and GraphQL APIs for the front end, and it also starts the Anvil node, which is the Ethereum development node from the Foundry toolset inside Nonodo. So when you type Nonodo in the command line, it will start all of those entry points. And then you just need to start your backend and your front end. So now I'm going to show really quick some print screens from the terminal instead of running, because I don't want to spend a lot of time on the presentation. So for instance, installing Nonodo is quite simple. You just download the binary from GitHub. It's already there, the version 0.10 for Linux. I also deployed versions for macOS and Windows, but I wasn't able to test it. So if anyone wants to test it and give me some feedback, I would be glad. But then you just unzip it and then install it in wherever you want, and then just run it. It's that simple. So running the application, as usual, with the host mode, you can run the Nonodo in one terminal session, and then in another terminal session, you start your application. For instance, here in the examples that I'm going to give, I'm going to start EchoPython application, which I took from the Rollups examples. So I just set the Rollup HTTP server entry point URL to the localhost 8080 /rollup, and then it will connect to the Rollup API from Nonodo and send the finish and wait for the next input. So handling advanced input is as you expect. If you send an input to the Ethereum Anvil node running in the host, Nonodo will read from it. It will add the input to its list of inputs to be processed. And then eventually the application will ask for the input. It will enter the processing mode and it will be processing this input. Then the application, for instance, is sending a notice here below, and eventually it will finish. So the Nonodo will log all this process, all these steps from the application, and eventually it will finish in the advanced inputs. The same thing goes for inspect. It works similarly. So but instead of sending the inputs to the Ethereum node, when you run inspect, you send the input to the inspect API, which is a different API, but just for inspecting. And then it's the same. It starts processing the input, it receives the reports in the case of the inspect, and then it finishes. And then in the other terminal, the application is running and doing the actual inspecting. Finally, the graphical API, like the production or Rollups node, it also has a playground for you to test it. So for instance, in localhost port 8080 -GraphQL, you can just type in your query and run it on the browser. You can also send the request from the terminal with curl, for instance. So it's the same. The API is the same. And another feature that I added in the end was the ability to read inputs from testnet. I think that now we are getting close to being able to deploy applications easily. It's already possible to deploy, but it's getting easier to deploy to testnet. So for instance, if you want to read the inputs from the testnet instead of reading from a local node, you can also do that. But you have to pass the contract addresses, the application address, the input box address, and the deployment block for the input box, and the RPC URL. I'm using Alchemy, for instance, so you need an API key. It's a little bit more setup, but also possible. Then, for instance, here for this application, this is exactly the EchoPython application deployed to Sepolia, and Nonodo read those inputs from the testnet, and it's adding them to the in-memory queue. And eventually, when the application starts, it will process those inputs. And that's it. The version 0.10 is out. It's on GitHub. And please send me feedback. Thank you.
Nice, very nice. I think the reaction in the chat says a lot about how it looks great. And just a reminder, Cynthia shared a link to the governance forum where the thought process behind Nonodo is presented in more detail. So anyone interested and get excited about this idea about Nonodo can check this link and understand the thought process and also contribute with comments. Maybe we can improve it. Right? Great. Next one, Danilo, can you come to stage, bringing all the projects that you look at?
Yes, hello everyone, good morning, afternoon, night. Let me share. Pedro, I think you are first.
Hello everyone, Happy New Year, great work in your Nonodo, really cool stuff. Just a really short slide because we did a really short release for 1.2. We just deployed the contracts of the infrastructure contracts on Habit from Sepolia and Habit and Operative Business Sepolia. So now we play for rollups on those networks. And we also, in the next slide, we deprecated Goerli for both. Since Goerli is deprecated overall in the Ethereum ecosystem. So the main stuff for the 2.0 release, it's almost ready. We finished the new interface for submitting claims. So now we have a set interface that the node can talk to, not only the reference node implementation, but any other attempt to implement a node. We'll have an easier interface to work with when submitting claims. And we also added a new claim storage smart contracts that replaces the history. It does the same things that the history used to do, but now it's inherited by the consensus contract. So we have to manage one less deploy contract in the infrastructure. Now, all relevant contracts implement the EIP 165. It means that you can query them and check if they implement certain interfaces. So if you have a dApp, you can go to the dApp contract and ensure that it implements the iCartesi dApp interface. So it's really used for front ends and for the Explorer too. Now, those are not really relevant, but we're renaming Cartesi dApp as application in the code base, just because dApp was a little weird on the camel case, and also because Sonodo and other parts of the stack are starting to use application instead of dApp. And we also removed Cartesi to make it shorter because it's also there's no need to say that's a Cartesi dApp, it's an application inside the Cartesi ecosystem. And the deprecated Arbitrum optimizable Goerli in this version. In progress, there is nothing really relevant, just to show that we're really close to the release. We're only missing documentation of some parts, some adherence to the utility style guide and tests. Because if you remember in the last presentation, we bumped Open and Zeppelin version, and we want to add some tests that covers some changes made at the Open Zeppelin imported contracts. Yeah, I think that's it. Thank you, everyone.
Thank you, Pedro. Next up is Dave.
Hello, can you hear me?
Yeah.
Yeah, okay. So for today, the updates that we have, that's not refreshed, Danilo. for some reason. Well, anyway, I guess I only really changed the order. So we did some cleanup on the repo itself by adding like documentation, README, instructions, because we do have a example running that it's actually scriptable. So you can add extra validators. You can try to add dishonest validators to see if you can like cheat the system. So we added some documentation for anyone who's trying to understand Dave to be able to enter the repo and actually know what's going on. And we did finish the clock implementation and also the Lua node that knows how to drive this clock implementation. And with that, we finished all these smart contract tasks that we have to showcase a Dave compute. So from this point on, what we're focusing on is trying to build a showcase that it's not rollups, it's compute. What call compute is like a rollups with no inputs. It's a one-shot computation. It runs from start to finish, and that's it. And we've reached enough maturity so that we can build a showcase, an interesting one, that you can use Dave to know what's the result of this one-shot computation. So all the other items are related to that. So we adapted the code that Carson and Zippie's team has given us. So thank you for that. We have a PR open for this Rust Dave compute. We are now also integrating the Dave compute in Rust, which is what we inherited from Carson, and the Lua node prototype that we wrote. So it doesn't really matter which node is really implementing, the dispute blockchain. You either use the Lua or the Rust one. And we're actually using this integration test is to use both. So you can have multiple players running multiple clients. So all of that is part of this effort to get a compute showcase. And if anyone has any examples that they'd like to see running on Dave, please send them to me. Carson already gave us a few interesting ones, but we're always open to more ideas. And yeah, thank you.
Thank you, Gabriel. Moving to the Explorer unit, Cartesi scan. So I'm going to present for Bruno. Cartesi scan has a new homepage. If you guys didn't see it yet, just go to cartesiscan.io. There's a new homepage, more summary driven. So I can open let me see if I can open the page here. Right, so this is the new homepage. It has the latest inputs on the left, latest applications deployed on the right, number of inputs, number of applications, and then from here you can go to a page for the inputs or a page for the applications. So, and also, let me go back to the presentation. What is the kind of input you want to send, if it's a ERC20 deposit or an NFT deposit or a raw input and so on. So it's more organized. And now the team is working on supporting ERC 721 NFTs, and also voucher execution is on the queue for the next release. Moving on to another topic, cloud deployment. Anderson and his team did some updates, decoupling infrastructure code from application configuration. This is to organize better the deployment of Cartesi nodes. And they also updated the staging production environments that are hosting the Honeypot application to the latest version of Kubernetes 1.28. You want to add anything, Anderson? That's okay. I'll move on. If he has something to add, he can join later. On the Sonodo front, we released the website. If you guys want to check out what is Sonodo, there's a web page now explaining what it is. Sonodo.io. We already had the docs.sonodo.io that provides some documentation about Sonodo. But the homepage now gives an overview of what is Sonodo. Basically, it's a service provider for Cartesi applications that we are building. And the main work in progress on this front is the Sonodo deploy. We are currently working on the front-end application. It's an application that you will use. It's a web application that you will use to deploy applications to testnet and mainnet. It also includes financial incentives for running those nodes. And I hope that in the next WCAT I can give you a tour and a demo of the system. That's it. Back to Claudio.
So the first thing to announce publicly is that we're going through this transitioning on our unit. It's getting a new scope, basically more focused on end user applications, let's say. And also the unit's transitioning to a new name called the App Experimentation Unit. So on the past month, what we did are a couple of interesting things on this direction. So we wrapped up a first version of the Python high-level framework for the Cartesi Rollups. It's available on this GitHub. And with this first new version, we also have a package available on the Python package indexer, PyPy. So now you can just Python install Python Cartesi and get started with it. So that's really interesting. This Python Cartesi framework that we've been working for a while, it's really non-opinionated, really vanilla. And we're developing a rebooted version of the Word Arcade. And for this version, we're actually deploying another higher level framework on top of Python Cartesi. This one is called Cartesi dApp currently, might change its name. And it's also being created on demand as we develop this new version of the Word Arcade. Right now it resides inside the Word Arcade repo directory. And it does speed up a lot of stuff, cuts up some templates that we generally use and stuff like this. But more on that later. So for this update, I'd like to focus on a demo for the Python Cartesi. It's a quick startup demo. It's using a template from Cookie Cutter, which is a well-known templating framework for Python. It's also making usage of the Sonodo toolchain, which is, for the ones that are not using it, it's highly recommended. It really speeds up as development and gets a much better experience. And Python Cartesi, it's also integrating with PyTest, which is the de facto way for testing Python applications. So it also brings a smoother developer experience. So quick demo here. So the first thing happening here is we're installing Cookie Cutter using pip. After we do that, we get started on this Echo Python-like template. So we just need what's the rep name, what's the package name, all stuff, and trace it. Then we enter the directory. This is the structure, so we have a directory with the tests, another one with the application code, another one with the basic files, like Docker file, readmes. But this is what a Python echo looks like. On this template, it's pretty simple. You have regular routing like you used on Web2 application frameworks like Django, Flask, and other stuff. Then using Sonodo to build it. And once it's built, we can just run it. So the Cartesi node starts, the application is online and ready to take requests. And on this other terminal, we just go there and use Sonodo send to send a sample input. In this case, on the simple input, we're just sending a hello world right now. You can see on the top terminal that the node gets that transaction, answers with a notice that just says hello world, just what you sent. And then we also test the application. So there are simple tests that's stressing this endpoint in which you send something and sends you back exactly the same stuff, right? So just installing the requirements of the Python application locally, and then we can just run this really simple test using PyTest directly. So yeah, guys, that's it. That's just to show how easy it is to develop a Python application using this Cartesi Python framework. It brings to a much easier quick start.
Essentially, stuff like carbon credit and forward switch G is kind of like, in our model here, it's basically one app chain each. A little bit like how, for example, a shareholder entity might be held or maintained by a particular company. And basically, having this stuff timestamped, high security dollar transactions. For example, let's say if ownership moves from one to another, it's quite important actually, as you're kind of like trading this about many different marketplaces. And we wanted to kind of like make it easy to add additional kind of like trustless verification of the assets, for example, related to standard confirm, honesty by asset confirmation, like for example, carbon calculation and so on. And what you can see here on the picture is basically what becomes trees. So we had some particular goals in this grant, but how we did it was that we built, let's say, something together with based on the Cartesi Rollups architecture using explicit sequencer. Basically, that when you make a new registry, it deploys a new app change in a state, because doing, let's say, 1,000 reforestation projects in this kind of manner with the established kind of roll-ups, like infrastructure, would basically be too expensive, too complicated to maintain infrastructure for, and so on. So we went with something where there's a lot of, let's say, scalability, possibility. And how it's implemented is that we have a state transition function. It's kind of like a Lambda style. It's an 80 megabyte container with TypeScript and Node.js on disk 5, thanks to Danilo's beautiful work in that area, with all the state hosted, stored into, and accessed by the front end over IPFS. And the container itself also being able to kind of like access IPFS through what we call the proto dehashing device. I'm speaking on kind of like on the real world assets team's path at the moment, but basically they reported a bunch of issues to us in the Bada and compute team, and on their kind of like on the backend side, they're kind of like sending submissions straight to the impact side. This is public good, so the repositories are available for you if you want to go take a look at it. We have a small demo, and Patrick will kind of like be explaining what's kind of going on here. You're able to see the video, right? So otherwise, we'll see. Patrick, you ready?
Sure, yeah, you're starting at it. Yeah, let's do it from the beginning. Okay, yeah, so this is the dashboard in Air Impact where for the carbon project, and this is especially the asset management part. So what we're doing here is that we're creating this carbon asset and we are signing like a first transaction to initialize it. So this is just like deterministic JSON. We are signing it with the integrated solution with Zippie dApp there. So what happened here was that we are actually sending this first transaction and initializing the app chain in Cartesi Lambada. So that could happen now in the background. And then the next transaction we want to do is that we actually want to issue these assets. So what we do here is that we are creating like 10 carbon forward assets, and we are signing it in the same way, and they are sent into Cartesi Lambada then as an X. And there are two types of, it could be a forward for a carbon credit. So now we just do that. So the carbon credit version of it. And what you see there is like a percentage. Usually when you like invest or buy these, you get like agree on the percentage you will get on the annual production of these carbon credits. And it will be sent here as well. There is another, so this Air Impact is communicating with another like service or API where we are sending this to Lambada, and they're also tracking for the updates and they take care of webhooks and stuff like that. So now there's a long waiting time. I think 5-6 minutes to get the first like get the app chain up and the first snapshot, and then read the outputs on. We publish the output on IPFS, so we can read it from there. And I don't know if you want to add something question here, or otherwise I think it's around 7:15. But we'll have
so basically, what happens here in the background? Is that the nodes pick up that there's a new app chain to be subscribed to, and it makes a snapshot at the point of getting a transaction and stores it, and then basically goes in and gets that ready. The snapshots are not that terribly quick at the moment, but in the later version we are now doing the snapshots in the background, so it is basically much quicker to get the first thing going. Also, we didn't implement APIs because it requires something on the sequencer side that monitors the inclusion of the transactions, and we just didn't have time to implement that at that point, but there's no reason why it can't be. Normally what you'll be seeing in a dashboard is that something's being created, there's a status on that's in the processing of it, and if something's getting included in a block essentially. And I'll just jump forward into the so okay, you'll continue, Patrick.
So here it was the first, we have the app chain and we have the first like initial transaction that was made. So we have like who is the owner of this, everything like that, all kind of metadata here. And then we are waiting for, so there are no assets at this point. That was another next transaction that was submitted. I think that we have around, I don't know the time right now, but around 9 minutes of the recording. We could jump there. And time to wait. Okay, here so this was the first 10 of them, the forwards, and they're opening up. So here you can see there is a thing, issue with the timestamp there. It says 2 years ago, but that was, the machine wasn't aware of the actual time. The customer had filed on that. And then we are waiting for the next transaction, which was like the carbon credits, and that will happen in, you could scroll to 10:40. Wow. Now the screen got back, Carson. Yes.
About 10:40, is it?
Yeah. 10:45. let's see, now it's refreshing. So now there's like 20 of these assets, and it will be on the next page. So that was the third transaction that we allowed. Running or processing inside Lambada and getting the output with an IPFS. And you will also see, I think I'm showing in the end of the recording, the actual output. So the output is actually just JSON files. You could go to, see, I don't see the time, 11:30. Yeah, but now it happens there. So yeah, it's just different JSON files here. And it keeps track of everything. And this is the actual, like the register of the assets there. That's what we were seeing in the front end as well. So yeah, thanks.
Thank you very much. Okay, so I'll move on to my own team's updates. Okay. So what we mostly been working on during December has been about Cartesi Lambada. We have a post on the technical vision forum. I would recommend you go and participate in the discussions and see what's it about. But basically what we did was publish kind of the first release and kind of the code published about this Lambada stack on GitHub. It supports at the moment kind of like Celestia on localhost and explicit sequencer, but it's not limited to that. It's something where we're kind of like basing something around Ubuntu 22.04 base image with IPFS inside that works to the outside world with Docker and C1. And what we have done is done this battle testing with the real-world asset project, basically having a real customer testing against our stack. And we also deployed the stuff to kind of like a test cloud instance, because right now the validation is essential. Let's say that you connect to an API and we trust what it's saying. We also made a speedrun video of less than 10 minutes where I started coding up an app chain, uploading it to the node, deploying and sending transactions to it. And since this is a different design, it's early days, there's implications, there's probably bugs, it's something new, but we think this is kind of like an interesting direction in how people can potentially adopt Cartesi technology. Building further upon this, we also been working on Cartesi Lambada coprocessor. So basically, again, we're free to post on the technical vision forum called Cartesi as a coprocessor. And the project is kind of like following this onboarding lifecycle that Eigenlayer is providing. And what it's doing is that it's reusing the Lambada stack kind of compute primitive as kind of the backend. And if you want to know, take out the source code right now, we're kind of like doing a squaring app inside it, but we have been testing kind of like 10 Eigenlayer operators in the local DevNet, and kind of like having the same environment as the Lambada stack is offering. The Eigenlayer guys do not yet have a ABS testnet, but we're hoping to be deploying this in a way where essentially you can take an application stored in IPFS as a Docker native Esquire Docker container and get it evaluated by the Eigenlayer restaking nodes that are signed up to be operators to this coprocessor, and basically get a majority vote on the computer result and settle it pretty much immediately to an Ethereum chain. Then, since I obviously got bored during Christmas, we have also been doing some additional things related to Cartesi and Bitcoin, and also there's a forum post. I would recommend you go and see some more details, but basically what I implemented during Christmas time was that I implemented RV32i instruction set, which is the barest instruction set you can kind of get for 32-bit RISC-V, to BitVM, which is kind of like this weird microarchitecture that BitVM people are doing, and it passed all the RISC-V tests for this instruction set, except for fence for some reason, I don't know. But what's happening at the moment is the BitVM team is kind of adopting some of the new opcodes that I needed in order to support this, and where BitVM is working as an architecture with Lake Tree as a local tree hashing instead. And this is kind of like just a little bit of a hobby project, but basically we're going to try to build the Cartesi machine into RV32i, basically the same way we're kind of like doing with ZK Linux, and we're going to bring a full-blown Linux machine into 32-bit address space. And yeah, you might want to do a Bitcoin soon, maybe. And the logo on the right, just to see that I have memo-making abilities, got adopted a kind of Telegram group BitVM, which has somewhat 1,200 users on it. So yeah, let's see. One of the things we are going to do related to this Lambada initiative is that we're going to have some calls on Friday where we're just going to synchronize, do some short demos, talk about process improvements. But if you're going to interested in a code walkthrough because you would like to learn more about Cartesi or the Cartesi stack, and you think about how we plan to develop things, then you're more than welcome. I also just want to make clear this is kind of like a grassroots initiative organized by the community. So don't bet the farm on it. If it's interesting for you, just feel free to join. But then it's going to be recorded in public if you can't attend in no time. So yeah, that's basically it. Technical and non-technical alike, feel free to join. Okay, thank you very much.
Milton. Come to stage, Milton. Yeah.
Hello there. Can you hear me?
Yes, here.
So what I'm supposed to do now?
You were curious about, so it's really possible to run Doom on
No, it's not.
Bitcoin.
It's not possible, but will it be soon possible? That's what we are curious to know. I think it's soon, right, Carsten? For what you said.
Well, you can run it on a Cartesi machine today, right? So
Sorry?
if we can run it on a Cartesi machine.
You can run it
already. So if we can make the Cartesi machine effectively run on top of BitVM with BitVM as microarchitecture, then I guess yes, we can run Doom on Bitcoin.
What's the? Can you give a general picture of what does it mean to run it on Bitcoin? Is something that I have no idea how that works.
So long story short is that somebody came up with an ability to do optimistic computation verification on Bitcoin, right? Like it's typically Bitcoin script is considered like very, very limited, but somebody actually managed to break the wall and get optimistic computation going. So they have kind of like a small virtual machine that can address up to, let's say, 32 bits of memory. Actually, it supposedly can actually address more if you really want to, but they have basically the whole thing with bisection steps working. And that's their small virtual machine. And what I did was that I implemented a transpiler from RISC-V into this microcode to some extent. Because it's quite close to RISC-V, so basically I can convert pretty much straight. And then ran all the tests that basically conformed this to match a RISC-V instruction set, and they passed. And then what I'm going to do is I'm going to build the emulator similar way we build the emulator for the microarchitecture that we have, and do machine swapping. And then, well, we can prove optimistically Cartesi machine to Bitcoin.
And what is an input in that scenario? I know very little about how Bitcoin network works. So, would you send some data somewhere? How does that work?
Yeah, you would send some data as part of a transaction somewhere, and that eventually gets stitched into something. And actually, I'm not completely sure. But having actual optimistic verification is a good start.
Sure. I'm just trying to figure out how things work and who runs. It's an option computation, and you pretty much the same would work the same as a compute environment for Ethereum. Or is something similar?
I mean, it's basically the same kind of like approach, but. It is like a little bit of a crazy project that's really capturing a lot of minds in Bitcoin at the moment.
Cool.
You can argue how it's useful, and that's kind of like why I'm doing it this particular part as a hobby project.
And just out of curiosity, so somebody figured out how to do an optimistic verification there. ZK is completely off limits. for that scenario?
I wouldn't say it. I wouldn't say it completely off limits, but it might be too expensive. But it's not. It's not something out the yes, and also it might be that you do optimistic verification or ZK verification.
Okay. I don't see the point of that. But
yeah. Fabio was asking about the dehashing device, and I think that's being studied a lot about this. In the Lambada side, we have implemented what we call the proto dehashing device, where we are having a little bit like a hypervisor sitting around the Cartesi machine, and by using yields in a way that they were probably not entirely meant to be used, we go in and read a flash drive after a yield, see that there's a particular hash, and then we store that into memory in a way that could potentially be done in arbitration side. But this is just what I said. It's a proto dehashing device, and it works as a dehashing device, but it's not necessarily the final way of a dehashing device, because you're supposed to do some extra things in a more standardized way and maybe protected by a kernel. But it's something that does exist if you really want to play with it.
So you are already answering the question about the hash device. Is that it?
Yeah, provided that that was the question I was asking. I was just wondering if I was muted while I was asking.
Yeah, so on that front, there's been these experiments going on the hash device, but like a final working implementation that really settles on L1 is not something that has been initiated. There are a couple, or more than a couple, of entries in the forum, and I expect these to actually something concrete to start pretty soon. That's my personal expectation, but let's see how it goes.
We have another one, Milton. From Crypto Gambler about honeypot. Honeypot dApp, what's the timeline for completion? Understand that there are still several issues outstanding per attached. He attached a picture from L to bit, but it's more about the decentralization stage. It's not something specific for the honeypot, right? It's something related to the rollups, Cartesi Rollups solution itself, and it's on our plan to follow the plan to decentralize the solution, right?
Yeah, so there's an explaining of what L2B actually means. So the honeypot dApp is a dApp, so it's a rollup, right, in itself, application-specific rollup. It's been deployed in the current stage of the Cartesi Rollups framework, which is the stage 0 framework, right? So there is no fraud-proof system installed. And that would be Dave, which we saw a presentation about it. Dave is going to start experimenting on the compute scenario now. So we have prototypes running. So at some point, we may have another rollup or other rollups that do have decentralization, which would already, I guess, be stage 2, right? If Dave is complete, right? Because Dave is already on permission. So the stages there are stage 0. Well, there are other factors, but regarding decentralization, stage 0 has no decentralization or not any fraud-proof system that can be verified by anybody. Stage 1 has whitelisted verifiers, right? So there is a fraud-proof system or something like that, but it's restricted to certain people to do that verification. So in case of Arbitrum, for instance, you have 8, 10 entities who are well regarded and do that validation. So they verify each other, and one honest player there is enough to ensure correctness of the state. And then stage 2 is permissionless, so anybody can participate in the validation of the rollup and ensure that it's correct. And that is what Dave provides. So we probably in that respect would be skipping directly to stage 2. But it would be a different rollup, right? It's not honeypot itself. Honeypot is complete as it is, with those caveats that it's a stage 0 rollup.
Right. We have another one from Lincoln. Hey everyone, thanks for the great insights shared today. Could you explain more about the difference between Sonodo and Lambada? I get their roles is making dApps deployment easier, but how are they different, and do we need both? Do we need both? Like to say something about that person?
I think we need both, essentially. I think that it's good that we have different approaches to doing things. Sonodo is at the moment using the current Cartesi Rollups framework, while stuff like Lambada is trying to take a little bit of a different view on how does the blockchain world look like. There's many projects out there and sequences and data availability and code processes and so on, and it tries to fit into that world primarily. It's quite normal that there's different approaches to things, especially in a decentralized ecosystem, and I think in the end of the day, like we'll likely end up seeing things more like a Cartesi stack eventually as a common like thing. But yeah, it's an interesting question.
I'll add, I'm not sure if Danilo wants to come on stage, but I see Sonodo and Lambada as different layers of that stack. So Sonodo is more like a convenience framework for development and deployment, and Lambada maybe is simpler in certain ways, that the convenience layer is different or requires different operations. But it's Lambada is more on the level of like rollups, Cartesi Rollups itself, right? So you could have like a Sonodo deployment system that uses Lambada underneath in some ways. That would be possible as well. So Sonodo is both a command line tool for packaging stuff and doing stuff, and also deploying. And then there is also the cloud infrastructure to run the node, etc. So I think it's on a different level. I'm not sure if Danilo wants to comment. Danilo's around. Yeah, and so Dave was pointing out here, at the current state, at least for Lambada is not settling on the base on Ethereum, right? So it's a different approach at the moment, at least. So I see like Lambada and rollups coming from different angles. So while rollups is as a rollup, a real rollup that is coupled with a Ethereum compatible base layer, Lambada is doing something from a different approach. It basically executes a computation on the Cartesi machine, and then you can plug that computation, which is deterministic, in some other system which is not necessarily an Ethereum-based rollup, right? So that's how I see it, Carson. I'm not sure if you want to comment on that, or that's what you see as well.
I think it basically comes down to how is this, because like in the end of the day, like what we are deploying is an app chain, right? Like the app chain itself decides how it wants to be settled or can be settled, and how does it prove itself to others, like for example the Ethereum chain. How does it settle? Those kind of things. And I think making a parameterization more an option of things is something that matters. And I also recognize that this is an interesting technical discussion, and I'm more than happy to actually take this on the governance forum as well.
We have another one from Lincoln.
Yeah, but Danilo, are you?
Just to complement, I think the question would be instead of a comparison between Lambda and Sonodo, the question is a comparison between Lambda and Cartesi Rollups, right? Just to make it more clear discussion. Sonodo sits on top of the Cartesi Rollups. It adds two things. It adds convenience for the developer, and it also adds a deployment system with a financial incentive, which is not present in the Cartesi Rollups core architecture. Right? So these two things, convenience and a financial incentive mechanism for node runners. But as Bruno said, we could also provide both things, the convenience and the financial incentive, to another framework that is not Cartesi Rollups, if that's the case.
Wow. Very nice. Lico asked another one about Nonodo. Nonodo is only the local host for devs deployment experiments, not suitable for production, right? Just a confirmation. As I listened for Lineo, yes, you're right. Yeah, Lineo is confirming here.
Yeah, not sure if Lineo wants to come on stage as well, but just to be clear, like Nonodo is a development tool for iterations, like the natural hard hat that Carlos said, but it's important to keep in mind that it's for quick iteration and not the real thing, right? That's why its name is Nonodo. It's not a node. Yeah. It's like emulating and giving a node feel for something that is not a node. And so when you're using it, it's not really running the Cartesi machine or doing anything. It's just mimicking what kinds of inputs and outputs you would get in your application, so you can quickly iterate, like host mode does today. But you really do need to package it inside and run things inside a Cartesi machine to get the real thing, right? So it's just a quick iteration experience, but not the real thing. So you should always test, run things inside a Cartesi machine every now and then to make sure that you are able to compile whatever you need in RISC-V, run anything that you need in RISC-V, and of course anything that is accessing your local machine to do some weird thing that would not happen inside a Cartesi machine. You should run it and make sure that everything is as it should be.
Yeah. Milton, I don't know if you share the same curiosity than me, but Vitor announced the Virtual implementation, and I was very excited about that, although we didn't discuss a lot about that. How it would improve the experience, even using Nonodo and all the high-level frameworks that we
like a lot as well. I'm not sure if anyone from the related team wants to come on stage, talk about that.
Yeah, I think, do you want to talk more about that, Vitor, or even Eduardo, if you want to comment? Not pressing, but just because I think it's a very nice feature for the developer experience, and I think it could be interesting to give more information about how it could be used, the potentials of that. Hey, Diego.
Hello. How's it going?
So is it host files mode? Yeah, we do.
Yeah, so remember that one of the main features of the Cartesi machine is, and in everything that we do in production, we want to be reproducible, right? And so obviously, if you are in production, we can't allow the Cartesi machine to connect to the network. We can't allow the Cartesi machine to take a look at the host file system, right? Because these things are going to be different depending on who is using it and at what time they're using it. It's like allowing the program to check the time of the day, right? Or use a mouse input or the keyboard input, right? How is this ever going to be reproducible? So obviously, these features are for prototyping. Now, what are these features, right? So the features are an ability to map a directory in the host to show up inside the Cartesi machine. Just like on Docker, you can use I forget it's -v or something like that, /v, something like that, right? To make a directory appear inside. Another thing is to allow the internet connections to work from inside the Cartesi machine. So you can do wget or curl or apt-get even, install and update and all things like that. Another one is not as dramatic, but is better support for the terminal, right? So you resize your window, and the terminal from inside Cartesi machine will be able to adapt and figure out that you actually resized the terminal. Things like that, right? So what can you do with something like this? Well, you can shoot yourself in the foot if you want, but you can also, if you use it for prototyping, it's going to be really cool. You just run Cartesi machine in interactive mode, prepare your rootfs, test your programs inside it in a single session of the Cartesi machine. When you're done, you can take a look at all the commands that you run and maybe script it in a way that is now actually reproducible, and so on and so forth. Maybe it provides an alternative to the host mode. I don't know. The sky's the limit. Just remember that this is a power that comes at the expense of reproducibility. But I'm excited to see what Sunodo is going to do with this, what Nonodo is going to do with this, and yeah, that's basically the idea.
Yeah, that's my curiosity. I don't know if Emil and Danilo already have some ideas about that, but I have the same feeling that it will open.
So one possibility is, remember when we are running for real, Rollups has a pretty sophisticated mechanism in which the machine yields, stops, some software from the outside writes the input, and so on and so forth, right? But if you're running in interactive mode and you're using the HTTP API, or even the new unified input API, which has a stub between the driver and the user code, you could have a program running inside the dApp, running inside the Cartesi machine, asking for a next input, and this actually being translated to an HTTP request on the outside of the machine to, say, the host mode or whatever is the new Nonodo thing, right? So you could have a lot of interesting things like this. You could have, for example, you run your program in a special way that if you modify the file from the outside, you're using VI on the outside or whatever editor you use, and you're editing the file and you change your script, and it automatically reloads without having to build the Cartesi machine or anything like this, right? So, yeah, so there is some intersection of functionality, and we're just increasing the range of possible development cycles that people can use, right? However they prefer.
Yeah, I think that's the point. That's the point. As there was a slide in the Neil's presentation about the development experience, and that was one workflow that was possible. There are several workflows that are possible, right? So one of them was that every time you change your code, you do the Cartesi machine again, and you do that way. And then there are discussions, right? Not necessarily you need to go that path. You can test things, do a lot of iteration, just on the back end with unit tests there, or even integration tests of your backend isolated from the rest. And sometimes people have workflows where they don't feel like they need host mode or things like that. And then, so on the other end of the spectrum, there are people who want to see everything working together and not necessarily having to install many dependencies like Docker, etc. So we have these different grades, right? So no node would be no free to run everything, but then you are further away from the real thing. And this idea of using this grid.io to have this host files mode or something, you would be really running the Cartesi machine, but with some leeway, right, for these non-deterministic.
So the way I personally see is everybody in the machine group already uses a feature in the Cartesi machine emulator to pass rollup inputs directly to it, right? I mean, most people will not know about this, but there is a command line that you can give to the Cartesi machine that you run it disconnected from anything, right? And you will pass a bunch of inputs to the dApp that is running inside, and will collect the outputs, vouchers, notices, whatever, and save them to disk, right? So it loads the inputs from disk and saves the outputs to disk as well, so that we don't need to hook an entire infrastructure just to test the behavior. But this is a batch mode type thing, right? And using the virtual.io and the network support and so on, we would be able to do this in an interactive fashion as well. So it becomes more flexible.
Can you provide a link for that too?
What? The command line tool? It's in the documentation. It's in
the Cartesi machine itself.
Yeah, the Cartesi machine.lua, it's in the help file and it's in the documentation as well.
Okay. I think that's it. If there is no more questions, we can finish. It was a nice call. Interesting questions. Lots of new features coming to bring a better developer experience. Very excited for this year. That's it. Any extra comment, Milton, or can we finish?
I'm good. Thanks for everybody.
Yeah. So that's it. Thank you, everyone. Happy New Year again. And let's build together a lot of interesting and useful things to bring value to the industry, to show the power of Cartesi technology solution and help bring new and interesting projects for this space. That's it, guys. See you soon in the next call, in comments in the governance forum, in comments in the Twitters, and all things that our marketing is announcing, sharing with you. Right? Bye-bye.